So good afternoon, everyone. I hope everyone remember what we have studied in last class, right? Tell me, everyone remember that? Yes? Just raise your hand, everyone. Just raise your hand. Okay, so we studied about electric field, right? What is electric field? What is the nature of electric field? Okay. What is electric field due to? Sorry, gravitational. Sorry. Even Abhiram told me, say guys, I guess by default, it's gravitational. Whenever I speak electric, gravitational. Okay, sorry. Yeah, we studied gravitational field, right? My bad. So we talked about gravitational field. Pranjal, actually, both are exactly same, right? Okay. So if you remember these concepts when we go to class 12th, you will realize that almost everything is same. I'll give a basic analogy between gravitational field as well as electric field. We will just change some constant. For example, G will be changed with K, M1, M2 will be changed with Q1, Q2. Okay, right? Otherwise, the formula will be same, exact same, right? There might be some changes in direction because charges are of two types, positive and negative. So their product may be positive or may be negative depending on the charges, whereas mass is just positive, right? So that is the only difference. Otherwise, almost everything, every formula that we will study in gravitation, okay, we will the same thing in electric field, electrostat, okay? Now, uh, thing is, whenever I taught, right, mostly I teach chemistry for crash course. Okay. When I used to go to Bangalore, I used to teach chemistry, like whole 11, 12th chemistry in like 4 months or 6 months. It's like that. So I used to get very less time. So I always used to teach both gravitational field or gravitation and electrostat simultaneously. So that's why this is I just picked this up. Okay, it's on my tongue because I was always a guest faculty for completing the portion in really short time, like whole organic in 2 months, whole chemistry in like 4 months, like that. So, okay. So we will start with revision. Okay, we will start with some concept test. Are you ready, guys? Concept test. Okay. So let's start some concept test based on what we have studied in last class. Okay, so this is first concept test. So this is our first concept test. What is the gravitational force between two bodies where A and B represents the center of mass of the bodies? So many people are saying A, some are saying B, some are saying D. So I'm getting three answers, right? A, B, and D. Okay, A and B and D. Now let's see what's the answer. Most of you are saying A, then second is B, third is D. Now, what do you know, right? When I talk about, this is the basic conceptual problem. Whenever we talk about, if you remember, whenever we talk about the distance, right? It is the distance between what, right? Let's see the answer. The answer is D, okay? The answer is D. Why? Only few people gave the correct answer. I've already explained this. How many of you remember? How many of you remember this? Tell me. How many of you remember the derivation of this? Rod 1. I hope everyone remember, right? And I clearly told you that I cannot take this distance was D and this distance was L by 2. L by 2. I told you that I cannot take this distance as d plus L by 2, right, from its center of mass and solve at g m1 m2 by d plus L by 2 square, right everyone? Tell me, did I explain this? Yes or no? Right? And when I was explaining this problem, I clearly told you that we cannot use this. Okay, so the answer is D. I hope all of you understood this concept now. Tell me yes or no, right? If these two would be spherical, then yes, you can say that the answer would be A, right everyone? Not A. In that case also the answer would be 16B. Okay, if it would be spherical, then it will be B, but not in this case. Right everyone? Tell me, got it? Yes or no? Okay? Okay everyone, right? Let's see the second concept test. Guys, tell me what's the answer? Tell me. Okay, so I'm getting two answers. Everyone, Khushi, Samya. Very conceptual problem. Okay, so now I got all the four answers. I got A also, B also, C also, D also, right? Now the question was at a point A, right? At a point A located near the body of mass m1, the gravitational field experienced by mass m1 is E. What will be the magnitude of gravitational field by mass m2, which is equal to 2m1 at the same point? Now, this is very basic question and the answer is C. I told you that gravitational field is the property of one object. Yes or no? Tell me guys, yes or no? Right? I hope all of you remember this concept. It has nothing to do with the other object. If you remember the basic formula, it is gm by r square, right? So unless and until this mass is not changing, okay, right, there will be no change in electric field, right? Got it everyone? Okay, so the answer is C. Next concept test. This I've clearly shown you these graphs. I've taught you, right? So which plot represents the variation of gravitational field with the distance from the center of the earth? Okay, right? So these are the four graphs. Tell me. No, Koshi, if you remember what we have studied in last class, I specifically told everyone, right? I taught it that how the gravitational field, right, G varies for solid sphere and how Earth is treated as solid sphere. No, Imba, you guys, please, you should have revised whatever we have studied in last class, na? Right? I've made the graph. Earth is solid sphere, right? Earth is solid sphere or hollow sphere? Tell me. Earth is solid sphere or hollow sphere? Solid sphere, right? And what is the graph of electric field, sorry, gravitational field due to solid sphere? What is the graph of gravitational field due to solid sphere? Or ask yourself, right? Yes, very good, Samarth, very good, Anaga, right? So the answer is A, right? This is the graph, na? Inside, right? Inside we have formula GMR by A cube. Yes or no? Inside the solid sphere, outside we have GM by R square, right? So when you talk about inside the sphere, it is directly proportional to R. So straight line. Outside it is inverse square law, right? That's why this is 1 by R square. Okay. So answer is A. Got it, everyone? Okay. Next. Okay. Okay, we'll see this concept afterwards, after completing the topic. Okay. Okay. So let's come to today's class. Okay. In today's class, we will discuss variation of G due to Earth rotation. Okay, because we are left with this part in last class. Then we will discuss gravitational potential energy and gravitational potential. But before that, we will try to derive the electric field due to finite length. Okay, right, everyone? Electric field due to finite length. Okay, so I hope everyone remember this problem, right? So how many of you attempted to solve this? Tell me, how many of you attempted this problem? Just raise your hand, everyone. No? Yes? Okay. So I'll explain this problem. NEET students and those who okay, so basically this problem will not be asked for NEET or JEE means, at least NEET in gravitation, but this same problem will be asked in electrostat. Okay, right? This problem will be asked in electrostat. Okay, everyone has to study this in electrostat, not in gravitational field, but electrostat. But since both are same, right, that's why I will try to explain it here. Okay, okay, everyone. So I'll just rub this one. Okay, now answer me, right? Guys, please answer me. So first of all, it is point mass or continuous mass? Think about it. I'll start from the very basic. It is point mass or continuous mass? Tell me. Sneha, please write the name of the students who are absent in the group, because many students are absent in the group. We have more than 10 students who are absent. Okay. Meet, please write the name of Meet and Jashan, write the name of boys who are absent in the group itself. Continuous, right? This is continuous. Yes, very good, everyone. Wait, I'll just use different pen. Okay. Now, if the system is continuous, I have to take a small segment, right? A small segment. Let's take this small segment, right? Let's take this small segment. Can you see this? Or wait, I'll just take purple one. This small segment, right? This is very small segment, and the length of the small segment is dx. Okay, dx. Right, everyone? Tell me. Okay, right? Now, how many of you know this? Okay, I hope all of you know trigonometry, right? Now, if you see, I'll just take this dx as okay, right? And this segment will make Sorry guys, I'm just horrible with diagram. I have to, okay. What is happening? That's the reason I can never draw a simple diagram. I don't want it to be start from here. Okay, better. Okay, right? Okay, guys. So you can see this. Yes. So that distance is dx. Okay, this distance is dx, right? And now, don't you think that this angle which is very small, this angle which is very small, okay, this is very small angle, and I call this angle is d theta. Okay, right? Anyone have any issue till this point? Tell me, anyone have any issue till this point? No? Okay, very good. And obviously this distance is x. Okay, so what is the formula? Tell me, start with basic formula. What is the formula for g? So dg, right? dg. If you see this, we talk about this one. Okay, we talk about this line. So this line, this is small line. Okay, this small line. So I can say that the field will be in this direction. The field will be in this direction. Yes or no, right? So if I make your coordinate axis, so this is the direction of field, right? Yes or no? Tell me, yes or no? This angle is theta. This angle I'm saying as theta. This angle is theta. Okay, this angle is theta. Anyone have any doubt till this point? I'm just stating the variable. Okay, I'm not doing anything else. I'm just using the variables. Okay, so till this point, I stated the variables. Okay, now what do you think? Which is the variable over here? If this is dg, it has two components, yes or no? dgx and dgy. So dgx is dg cos theta and dgy is dg sin theta. Yes or no, guys? Tell me, yes or no? Step by step, right? Yes or no? Okay. And what is dg? dg is the magnitude of gravitational field, okay, which is capital G into dm by r squared. Okay. Okay, guys. Anyone have any doubt till this point? Step by step. Anyone have any doubt till this point? Everyone should get this. Everyone. Every single student should get this. Anjali, are you getting? Chulika, Samya, Meet, Pranjal, Priyanka? Preetham is not here, I guess. I just use the basic formula. Okay, I just use the basic formula. dg is equal to capital G into dm by r squared, right? Because I'm taking this small section and the mass of the small section is dm na, right? Right? So I can say that I'll just use some variables over here. So lambda is equal to capital M by L, okay, and dm is equal to lambda into dx, right? I hope everyone remember this. Dm is equal to lambda into dx. Okay, Karishma, you got this? Okay, very good. Now you have two things. Either you have a, like, in terms of distance, right? Either you can solve this in terms of distance, or you can solve this in terms of angle. Okay, right? Now when you solve in terms of distance, you have difficult integration, right? So I won't suggest you to solve in terms of distance for now. Okay, and I will teach you to use angle as a variable, because just think about it, right? If this angle will change from alpha in this direction and beta in this direction, you can get the whole length. Yes or no? Tell me, guys. Yes or no? Right? And this distance is your r. This distance, I'll just use the red pen. This distance is your r, right? So I can say that r and theta, r as well as theta, are related. Yes or no? Yes or no? R and theta are related. Right? How come it is related? Let's see. We know that this is a right angle triangle, this is a right angle triangle, this is x, this is d, this is r. So I can say that cos theta is equal to d by r. Yes or no? Tell me, guys. Yes or no? Cos theta is equal to d by r. Right? So r is equal to d sec theta. Anyone have any issue in this point? Okay. Okay, guys. And how many of you know this? dx, can I write dx is equal to r d theta? Tell me, can I write dx is equal to r d theta? How many of you know this? I hope all of you have studied this, right? Arc angle L is equal to r theta, or theta is equal to L by r, the basic definition of radian in trigonometry. Everyone remember this? Okay, very good. So okay, so this is the prerequisite. This is what we should know. Now, anyone have any doubt till this point? I hope no one should have doubt till this point. Yes? Okay, right? So let's see, let's solve, right? Let's solve now. So I want to find dgx for now, because obviously dg is just the magnitude, right? I need to find either dgx or dgy. So dgx, let's find dgx first. So dgx is dg cos theta. Okay, dg cos theta. Sorry guys, here we cannot use this. We cannot use this because we have a relationship. Okay, we have a relationship between theta, x, and this d, right? And that relationship is x by d is equal to tan theta, right? We have this relationship, okay, right? And I could have written dx is equal to r d theta when this theta is very small, right? But this is not, this big theta is not very small, right? Okay, so I have to use this relationship. So x is equal to d tan theta. Okay, this is the relationship that we will be using, because here theta is changing and theta is not very small, right? This theta, this is d theta, I understood, right? But this theta is variable. This theta is variable. Okay, so I'll be using this relationship. Yes, d theta is small, right? But after integration, and we have a relationship between x and d where x is variable. Okay, right? So I'll be using this relationship, x equal to d tan theta. Okay. Now, if you solve this, if you solve this and try to find dx, right, using differentiation. So what do you think? Dx by d theta is equal to d. What is the differentiation of tan theta? Tell me, guys. What is the differentiation of tan theta? I hope everyone remember sec square theta. Yes, sorry, d theta. So dx by d theta is equal to d into sec square theta, right? Right, everyone? Or I can just write dx is equal to d sec square theta d theta. Dx is equal to d sec square theta d theta, right? See, this is d theta and this is the distance d, okay? Right? Got it, everyone? Tell me, got it? Got it? Okay, right? Now let's put the value. Let's put the value. So dg, what is dg? dg is g dm by r square into cos theta, okay, right? And this is dgx, integration 0 to g, and this is integration from where to where, right? I don't know, because I still don't know what is my variable, so I'm not putting any limit over here. This can be written as, see step by step, everyone see step by step. G dm is lambda dx by r square. What is r square? We calculated that r is equal to d sec theta. So r square is d square sec square theta, okay, into cos theta. Okay, let's see this. Now g lambda dx. What is dx? dx is d sec square theta d theta. Integration of d sec square theta d theta divided by d square sec square theta, okay, into cos theta, Anyone have any issue till this point? Tell me, anyone have any issue till this point? Any issue till this point? I just substituted the value. Karishma, are you getting? Koshi, Samya, Pradyumna, Anjali. If you're not getting, please let me know. I just substituted the value. I didn't do anything else. I just put the value of lambda. Lambda is common. Just see step by step, right? dm, I put lambda dx. Okay, r square, I put d square sec square theta, right? From this step to this step. Then dx, okay, lambda since constant I've taken outside. dx, I put d sec square theta d theta. That's it. That's all I did. I just substitute the values, nothing else. Okay. Now, if you see this, we will get g lambda by d, right? D will cancel this sec square cancel. We will have cos theta d theta. Yes or no? Tell me, yes or no? Right? Yes or no? Tell me. Anyone have any issue till this point? Tell me, yes or no? Try to understand step by step. This is how many steps? This is basic definition, 1 step, 2 step, 3 step, 4th step, right? This is your 4th step. Okay, see how simple it is. Now, how simple it is. I hope all of you know what is the integration of cos theta. Tell me, guys, what is the integration of cos theta? Yes, minus sine theta. I still didn't put the limit, right? I still didn't put the limit. Okay, right? So it is minus sine theta. Now let's see the limit. Let's see the limit. The limit is this is alpha angle from here. I'm calculating the theta from here, right? So from here, this is alpha in this side and beta in this direction. Yes or no? Tell me yes or no, right? Samarth, integration of cos theta is minus sine theta, na? It's not differentiation, right? It is integration, right? No, integration of cos theta is sine theta. Differentiation of cos theta is minus sine theta. Yeah, it is sine theta. Okay. Okay. So if we take the value, right? I'm taking the value. So one angle is opposite to other angle. Yes or no? One angle is opposite to other angle. So if I'm taking the upper angle as alpha, the lower angle should be minus beta. Yes or no? Right? Right, everyone? Okay. Got it? Why I have taken alpha and minus beta? Because one angle, right, is in this direction, another angle is in this direction. So they are in both directions, right? So if one I'm taking as alpha, the second should be minus beta. Okay. Now put the value, guys. So we'll have g lambda by d. After putting the value, we will get what? Sine alpha minus of sine minus beta. Yes or no? Tell me yes or no. Yes or no? Which is basically g lambda by d sine alpha plus sine beta. Agree, guys? Agree? Tell me yes or no. Yes or no? Okay, Abhiram, understood? In the same way, can you calculate gy? Can you calculate gy? Tell me what is gy? Same thing, right? G lambda by d integration of sine theta d theta minus beta to alpha. Yes or no? Tell me yes or no. Right? Directly, can you write directly this? Gy is equal to g lambda by d, right? Sine theta alpha 2 minus beta. Okay? Right, everyone? Which is basically g lambda by d minus c cos theta minus cos theta, because integration of sine theta is minus cos theta, right? Alpha and minus beta. Okay? Right? So we will get g lambda by d cos beta minus cos alpha. Okay? Tell me, guys, yes or no? Tell me yes or no. Anyone have any doubt? Tell me. Samya, Anjali, Mansi, Sumaya is out many days. Khushi is absent today. Mansi, are you getting? Step by step, right? I'll explain once again. Okay, I'll explain once again, right? You guys just need to remember this formula. If you don't remember the derivation, okay. I guess Sumaya is not in town. Sumaya is in Hyderabad, some checkup, I guess. Okay, guys. Now tell me, suppose if I talk about infinite line, just think about it. If it is infinite line, what will happen to alpha and beta? Tell me. If the line is infinite, what will happen to alpha and beta? What would be the value of alpha and beta? Yes, very good. It will be almost 90 degrees. Yes or no? Tell me, guys. It will be almost 90 degrees. Yes, very good. Very good, everyone. Now, if it is almost 90 degree, so what would be the value of dgx? Let's see, right? Let's say the case, special case 1, okay, which is infinite lines at both end, okay. So in this case, alpha is equal to 90 degree and beta is equal to minus 90 degree, right? Okay, or I'm just talking about the value, right? So I'm just talking 90. I'm just talking about the value. So it will be just gx. I have written dgx here. It will be just gx now. Okay, yeah, I have written gx. Okay, so it is gx. So gx will be, tell me, g lambda by d. Okay, sine 90 1 plus again 1. Yes or no, right? Sine alpha plus sine beta, 1 plus 1, which is 2g lambda by d. Okay, and what about gy? Gy will be g lambda by d, 0 minus 0, which is 0. Okay, okay, Sneha, Samya, Akshaya, Amish, Siddharth, Ronak. Siddharth is okay. Siddharth is having some issues, I guess. Shriyari, Tulip, Anamika, everyone is getting. Tell me. Very good, Tulip. See, when we talk about this relationship, when we talk about R is equal to, right, or L by R is equal to theta. Okay, this is this relationship. Let's see. This is this relationship, right? If this is L, and this is R, then this is theta, right, everyone? Yes or no? Yes or no? Now, can I say that? If this is R, this is X, right? And this is d theta. Okay, this is d theta. Now, if I don't have any other option, right, then I will take d theta, dx is equal to r theta. But here it is a right angle triangle. And I have a relationship between x and r. Okay. Now, don't you think which of the two, this or x is equal to x by d is equal to tan theta? Which of the two would be better relationship? Tell me, which of the two will be better relationship? Right? And we will use this mostly in spherical system. For example, disk and ring you can use. Okay, right? Okay, got it, Samarth? Okay, so now this is special case 1. Special case 2, one side infinite, one side finite. Okay, so you can have any special case Because this is a general formula, right everyone? This is the general formula. Yes or no? Tell me, yes or no? Okay, okay. So I hope everyone is clear about gravitational field. Everyone's concept is clear about gravitational field. Now there's, see, if I have to teach, there are lots and lots of things which can be taught, right? There are some things, some extra derivations, okay, that we'll be doing in advanced class. So those who want to attend, they can attend. Those who just want to see the videos, they can just see the videos afterwards, right? Okay. Okay, so we will start the next topic, which is gravitational potential energy. I hope till this point everyone is clear about gravitational field. Yes. Okay. Yeah, sorry, we won't be studying. We have last topic, right? Yeah. So this is variation. The last topic is variation of G due to Earth rotation. Variation of G due to Earth rotation. Now, what do you think? What impact Earth rotation will on gravitation? Now, just think about this. Just think about this. What is gravitational force? It is a kind of force. Yes or no? Yes or no? Tell me. Right? And when anything rotates, okay, right, there's another type of force which come into action. What is that force? Tell me. What is that force? We have studied in circular motion, right? Yes, centripetal or centrifugal, right? Centrifugal, okay, which is outward force, right? In atomic structure also we studied the same thing. Yes or no? Right? In atomic structure we studied the same thing, that toward the nucleus we have centripetal force, which is electrostatic force, and away from the nucleus we have centrifugal force. Okay. Now, don't you think that when Earth rotates, right? When Earth rotates, there should be same kind of concept, right? So suppose someone is standing over here. Suppose someone is standing over here. Okay. So there will be a force in outward direction. Okay. Right? Which is your centrifugal force. And centrifugal is mv square by r or m omega square r. I hope all of you know this now. Tell me yes or no. I hope everyone know this now. Okay, very good, everyone. Now, let's see the free body diagram. Let's see the free body diagram. This is just a problem of Newton's law of motion. Okay, this is just a problem of Newton's law of motion. Right? Just see this. Okay, see this. So we have, I hope all of you can see this, right? We have m omega square r in outward direction. This is the outward direction. Okay, because Earth is rotating like this, right? The circle is this one. Some people might think, so why not this? Because Earth is rotating like this one, right? So the circle is this. Okay, this circle, right? This circle. I'm talking about this circle. Yes or no? Okay, so if I'm talking about this circle, the outward direction is this. Okay, right? Now, we have mg in this direction, we have mg in this direction. So I'll just use another, yeah, I'll just use another axis to represent that. Okay, I'll just represent another axis. Now we have this is the direction of mg. So this is the direction of mg. This red one is the direction of mg. Okay, everyone, right? Yes or no? Yes or no? Tell me. And this angle is lambda. This angle over here I have taken as lambda. This angle is lambda. And we know that we have in this direction, which is m omega square r, Okay. Okay, everyone. Anyone have any doubt till this point? Tell me, anyone have any doubt till this point? No, Sneha, mg is just toward the center. That's it, right? Okay, I'm just talking about mg toward the center. As simple as that, right? I'm just taking xy axis only. At one point, at one position, I'm taking. Okay. Okay. Now we know that I want to find G. I want to find G effective. I want to find G dash, which is total force on the object. Now G is in this direction. And because of this, we have one component in this direction. And what is that component? Since this is lambda, this is also lambda, right? This is also lambda. Yes. Okay. I want to find this component on this. I want to find this component on this. So can I say that this component, I'll just name it as G naught, right? So G naught is equal to m omega square r cos lambda. Yes or no? Tell me. Yes or no? Tell me. Can I write G naught as m omega square r cos lambda? Okay. Yes. Now tell me, along this axis, what is net G? G net G. Can I say that net G is G, right? G, which is in this direction, minus G naught. Yes or no? Because the direction is opposite, right? Due to earth gravity, the normal G is in this direction, but because of rotation, there's a centrifugal force which is outward direction, right? Okay. By M. Force by mass, na? G naught is force by mass, right? By M. So omega square, sorry. Or I can just say the F net is equal to F due to gravity minus F due to centrifugal into cos lambda. Okay, right? Tell me, yes or no? Yes or no? Till this point, everyone is getting the concept? Okay? Okay, so if you put the value, we will get what? G net is equal to G minus omega square R, because it is G, right? Mass will be F by M will give you G now. Cos lambda. Okay, right everyone? Tell me yes or no? Yes or no? Okay, so at equator, what do you think? At equator, what will be the value of lambda? At equator, what will be the value of lambda? 0. So what is cos 0? What will be cos 0? 1, right? So G net will be minimum at which point? Tell me, G net will be minimum at which point? Equator, right? Very good. Okay, very good. And maximum at which point? And maximum at which point? Poles. Got it? Right? So there was a simple problems also, okay, based on this, that G is, if you buy a sugar from some place to some place, the weight is different. How is it possible? Right? So frankly, it's not the mass which is different, it's the weight which is different, right? Which is the force due to gravity, okay? Or G, which changes. Anyone have any issue in this? Tell me, anyone have any issue in this? Okay, so what will happen? What will happen if Earth stops rotating? What will happen if Earth stops rotating? Tell me. No centrifugal, no this term, right? So G net will increase, na? G net will be equal to G. It will increase, right? So suddenly we feel more acceleration due to gravity. Okay, okay, not okay. So this is the short, yes, this is the short calculation and this is the detailed calculation. Okay, if you want to study, this is the detailed calculation. And this is the easy one, the easy one. It is not a book. I have just made a PPT. I'll just share this PPT. Okay, sorry guys. Yeah, I just missed one square because this is your G dash, right? This is your, this is, yeah, this is your MR omega naught cos square theta, right? But this R, I just wrote this, right? G net is equal to G minus omega square R cos lambda, right? So this R is not Earth radius. Okay, this R is not Earth radius now, right? So I was writing this equation. Now, if you want to convert into Earth radius, then again you have to use one more, right, component. Okay, so we know that R, this R and this R. So R is equal to what? Tell me. It's a component of Earth radius, yes or no? So small r is R into cos lambda, right? So I have to substitute this also, right? So when I wrote this R, which is the radius of the small circle. So if you put the value of small r in terms of radius of Earth, you will get G net is equal to G minus omega square capital R cos square lambda, right? Okay. So this is in terms of the radius of small circle and this is the radius of Earth. Okay. Got it? Right? Got it, everyone? Don't worry, I'll share this PPT. I'm making this PPT. I'm just inserting good questions also from all the different textbooks and notes that I feel good. For example, see the lecture to have inserted these questions, notes, right? So I'll share this with you guys after the chapter is completed. Okay. So I'm trying to find all the concepts from all the materials, good books, and I'm trying to make one PPT. Okay. So that you need not to search many books. Okay. So I hope everyone got this concept. Raise your hand. If you got this concept, please raise your hand. Right? Okay, very good. Very good. This we have already studied in last class. Sorry, not this one, last one, this one. Okay. So the next concept, yes, the next concept that we are going to study is gravitational potential energy, right? I hope everyone know this, right? What is the potential energy due to gravity? Tell me, what is the potential energy due to gravity? Everyone know this formula. Tell me. mgh. Everyone know mgh, right? Yes. Anyone who doesn't know mgh? We have used this now. Okay. In class 9th, right? Acceleration due to gravity, mgh. Yes. Now we will try to understand what is the meaning of potential. What is the meaning of potential? I'm just talking about the potential. I'm not talking about gravitational potential or electric potential. Okay. So I'll just talk about potential. Okay. So the next topic that we are going to discuss, is potential. Okay. So let's give the heading potential. Or I'll just give the heading potential energy, because potential energy and potential are two different things. Okay. Potential energy and potential are two different things. So for now, I'm just saying potential energy. Potential energy. Right? Now let's try to understand this intuitively. Let's try to understand this intuitively. I hope all of you have played with spring. Right? Okay. Right? Yes. Now, if you stretch this spring, right? You're applying force, yes or no? If you stretch the spring, you're applying force, right? And this spring will expand like this. The spring will expand. Yes. Okay. So can I say that, okay, I've studied the concept of work by energy, right? I'm applying a force, okay, I'm applying a force, and displacement of particle is happening, right? Right? So there's force and there's displacement. So obviously I'm doing work, right? Obviously I'm doing work. Yes or no? Yes or no? Right? Yes? Okay. And we have studied that if we are doing work, there must be some energy involved. There must be some energy involved, right? Right, everyone? So if we, yeah, if we just, I got a call, that's why I was disconnected, right? Yes. So let's recall the concept. Let's recall the concept of last chapter, which is work energy theorem or conservation of work, right? So what was work energy theorem? Tell me, what is the law of conservation of energy? Anyone? Tell me, what is the law of conservation of energy?
Energy can neither be created nor can be destroyed.
Okay, just message me in the chat box. So the basic statement was work done by conservative force, right? Plus work done by non-conservative force, right? Tell me, is equal to delta K, changing kinetic energy? Yes or no? Tell me. Yes or no? Right? Work done by conservative force plus work done by non-conservative force is equal to delta K. And we know that when we know that work done by conservative force is equal to negative of change in potential energy, right? Because if we do work on something, right, then that energy is stored, right? That energy is stored by the object either by the virtue of its configuration, right? That's the basic definition of potential energy, right, everyone? Yes or no? Yes or no? I'm just revising the concept that we have already studied. And so I can say that the general expression for potential energy is minus W due to conservative. Minus W conservative. Yes? Okay? Or I can just say that like this, minus integration of f dot or f dx, f dot dx. Anyone have any issue? Tell me. Anyone have any issue till this point? Think about it. Any issue till this point? Means if you're bringing any object, from point A to point B, if you're bringing any object from point A to point B against any force F, right? Okay, or even in favor of force F, because it doesn't matter. Dot will give you the direction, right? If it is against, then angle will be 180 degree. It is toward, then angle will be 0 degree. So you don't have to worry about that, right? Then you will do work, right? If you are bringing against then you will do work, right? And that work will be conserved in form of potential energy. Yes or no? Tell me, yes or no? Right? And if the object is moving in the direction, right, of the force applied, then the potential energy is consumed in work done, right? So I hope all of you remember this concept. Yes or no? Okay, so doesn't matter what this force is, doesn't matter what this force is. This is the general statement that we all know and we all studied in work power energy, right? Now, depending on this force, there can be different type of potential energies. That's the thing, right? So why I told you about this in general, because if you use F as gmm by r square, you will get gravitational potential energy. If you will use, because F should be conservative, this force should be conservative, that's the thing, right? This is your conservative. So I can say that if I'm having eight, yeah, what happened? Yeah, if I'm having F is equal to g m1 m2 by r square, right? This is your gravitational force. If I'm having F is equal to k q1 q2 by r square, this is your electrical force, right? Fg Fe, but both are conservative. Yes or no? Both are conservative, right? Okay, so I can define potential for both of the forces. Yes or no? I can define potential for both of the forces, right? It will be the negative of work done. It will be the negative of work done by a conservative force to bring an object from one point to another point. Yes or no? Right? Now, when I talk about gravitational potential energy, the definition will change like this. It will be the work done, right, against, right, or negative work done, right, against the gravitational force. Yes or no? Right? Instead of conservative force, I'll just use gravitational force. Okay? Right, everyone? Anyone have any issue in this? I just use the concept that we have already studied. Now let's try to find the, yes, let's try to find the formula. So minus integration of F. What is F? Tell me. If I'm bringing any object from point A to point B, right? From point A to point B. Okay, I'll just take this scenario. Okay, we have here mass M1, right? Capital mass M1, and this is small mass M2, right? Initially it is at point A. Now I'm bringing it at point B. Okay, so the distance of point A is RA, and distance of point B is RB. Okay, everyone, right? We have this distance. Okay, now I want to find the work done. I want to find the work done from point A to point B. Okay, now think about this. Think about this. F is in this direction. Yes or no? F is in this direction. Yes or no? Tell me. Yes or no? Gravitational force is always attractive. Okay, and dx is also in this direction. Displacement is also in that direction, right? Okay, dx is also in this direction. Nah? So f dot dx is just f into dx. F dot dx is just f into dx because the angle is 0. So cos 0 is 1. So f dot dx can be written as just as f dx. Okay. Now what is the formula and what is the limit? It is RA to RB. RA to RB. Okay, from A point to B point. So it is minus integration of, what is the formula for F? Tell me. G m1 m2 by r square. Yes or no? Yes or no? Right? Into, or x square into dx. Anyone have any issue till this point? Tell me, anyone have any issue till this point? Tell me, guys. Step by step. Anyone have any issue at this point? No? Very good. Now, can I say that, okay, G constant, M1, M2 constant, so I'll just take minus G, M1, M2, integration of dx by x square, RA to RB. Okay. What is the integration of 1 by x square? Tell me, guys. What will be the integration of 1 by x square? Anyone have any doubt till this point? 1 by x square, Samarth, it is not 1 by x. We have discussed this, right? X square, x to the power minus 2 is, tell me, x to the power minus 2 plus 1 by minus 2 plus 1. This is the integration, right? Right, everyone? So it will be minus G M1 M2 minus 1 by x, right? RB RE. Okay. So if you see this, we will get G M1 M2 1 by RB minus 1 by RA. Agree? This is the basic formula. Yes or no? Tell me, yes or no? Right? Now, if you are bringing any object from infinity, then tell me, RA will be infinity or RB will be infinity? If we are bringing anything from infinity, then RA will be, tell me, infinity. Yes or no? Yes or no? Right? Then 1 by RA will be 0. Then this expression will become minus G M1 M2 by RB. Okay? Okay? Got it? Tell me. And what is this? This is UB minus U infinity. Right? Final mass initial. And this will be UB minus UA. Delta U, that is final mass initial. Okay, yeah, sorry, my bad. Minus and plus. Yeah, minus plus, right? So this will be, if RA is infinity, then this is plus. Okay. Anyone have any issue on this point? Anyone have any issue till this point? Tell me. Clear? Everyone is clear? Everyone is clear? Just raise your hand if you are able to understand everything. Please raise your hand. Okay. So this is what I explained, right? So this is what I have explained. I've explained each and everything. Okay, right? So this is the work done. Work done is, right? Work done is G M1 M2 1 by RB minus 1 by RA, right? Which is minus integration of F dot dr. Okay. If you're taking it, wait. See, it depends on the direction, right? In which direction you are taking it. Okay. What happened? Okay. So here it is taking A to B, and A is B is far away, right? So it is in opposite direction. That's why, right? That's why it is negative of what we did, right, everyone? Yes or no? Tell me, right? So when we derived, I have taken this B point as A point and this point as B point. So do not get confused. Do not get confused in the notation, right? Try to understand in the same way as I did. Okay, you will never ever get any confusion. Okay, right? Try to understand from the very basic. I hope all of you understood this very basic thing. Okay, very good. Now, next concept. Okay, so this we have already understood. Okay, now this is if you are taking one from any point to infinity, this will be the potential energy. Okay, let's see some points. So can I say that, right? Just see this. If I can say that du is equal to minus f dot or f dr if it is in same direction. Okay, right? Okay, can I say that du by dr is equal to minus f? Tell me yes or no, right? Or f is equal to minus du by dr. Make sense? Tell me, make sense? Right? Because if integration of force will give me, right, potential energy, so opposite should happen, right? Differentiation potential energy should give me force. Okay, okay. Now the second concept is how come we got mgh as our potential energy, right? How come we got mgh as potential energy that we use? Okay, right? From r to h distance. Now see this, right? This is basic. Now when we talk about point A to point B, I'm taking away, right? So what is point A? Point A is radius of earth. Yes or no? Point A is radius of earth, and point B here is radius of earth, right? Plus this height h, where it is taken as y. Okay, right? Now, if you solve this and use a bit of binomial theorem, right? Same binomial theorem, 1 minus y by r to the power minus 1, or sorry, 1 plus to the power minus 1 will be written as 1 minus y by r, right? If y is very, very less than r. Yes or no, guys? Tell me yes or no. Think about it. Yes or no? We have studied this, na? Last class, right? So see, 1 by, if I take 1 by RE common, so 1 by 1 plus y by RE. So this is 1 minus y by RE, and 1 will get cancelled, right? So I'll just think about this term. So minus minus plus. So I will get this relationship, right? If I solve this, I will get gm1 m2 by r square, right? R square into m h, if I'm taking as height as h, or my, which is height. Now what is g m1 m2 by r square? F, sorry, here I have written m twice, my bad, right? So g m1 by r square into m2. What is g m1 by r2? This is g now, right? Association due to gravity. So can I say that m2 gy? This is the formula that we use, right, everyone? So I hope all of you understood how come we got this mgh as a potential energy formula, right? And this can be used, right, when y is very, very less than radius of earth. Okay, okay. The last point is this, right? The last point is this. Now, as we know superposition in force or gravitational field, right? What about gravitational potential energy? Suppose we have a system of n objects. So here I'm taking 3 objects, m1, m2, and m3. Guys, is it clear to you guys, or should I zoom it? I don't know if I can zoom it, by the way. Or should I write it? Tell me, guys, is it visible to you guys? Clear? Okay, very good. Okay, so see here, right? Okay, here I've taken a system of 3 objects. Now, if I want to find the potential energy, what is the meaning of potential energy here? Tell me. what will be the meaning of potential energy? Think about it. If I want to find the total potential energy, total potential energy, total U, what will be the meaning of total U? Now, don't you think that if I talk about this potential energy, right, I can say that okay, that would be the negative of work done to bring all this together. Yes or no? Tell me. Yes or no? Right? From infinity to this point. Yes, agree. So I can say that okay, the potential energy of the system or particle of system will be equal to negative of work done, right, from bringing those particles from infinity to a given point. Yes, agree everyone? Agree? Okay, so yes, so when we talk about these three particles, there will be potential energy between 1 and 2, there will be potential energy between 1 and 3, and there will be potential energy between 3 and 2, right? So can I say that the total potential energy will be the potential energy between 1 and 2, 1 and 2, 2 and 3, and 3 and 2? Yes or no? Tell me. Yes or no? Right? So yes, very good. Very good, Samarth. Okay. So I can say that, wait guys. Okay. So I can say that U total, right, will be, okay, U12 plus U23 plus U32, sorry, 31. Okay, right? Okay. So if you see the statement, right, what is the statement? If our system contain more than two particles, we consider each pair of particle in turn, right? Calculate the potential energy of that pair with equation, right? Okay, if other particle was not there, right, and then we just add it algebraically, because potential energy is a scalar quantity and we know that we can add scalar quantity algebraically, right, because it is F dot dr, work done is scalar quantity, so obviously potential energy will be scalar quantity, right? So here we will have U is equal to minus Gm1 m2 by R12, Gm1 m3 by R13, Gm2 m3 by R23. Okay, right? Anyone have any issue in this? Anyone have any issue in this? So potential energy is a scalar, U is a scalar, right? Whereas force and field are vector, right? So I hope no one have any doubt till this point. Everyone is clear? Okay, very good, everyone. Okay. Okay. So we have covered potential. Now you might be wondering why I was having this positive sign and why I'm having this positive sign, why in this textbook it is negative sign. I hope all of you understood, right? Why? Tell me. Yes or no? Right? Because here I'm taking a particle from A to B, okay, which is away from the object. And in my case, I was taking in the direction of that, right? So that's the opposite direction. That's why. Okay. I hope all of you understood that. Yes or no? Right? Because if you see the fundamental basic equation, right, F dot dr, so in my case F dot dr was positive and here F dot dr is negative, right, because this is the basic mistake that every student do, okay, in the direction. So that's why please just start from the very basic. If you ever get confused, okay, just think logically. If anything is going against the work done, right, if anything is going against the force, right, against the force, think about it. If anything is going up against the force, right, work will be done. Yes or no? Tell me. Yes or no? Right? Work will be negative, right? A potential will be positive. So this will explain here. W is minus integration of f dr, not f dot dr, f dr, right? And when I derived it, okay, it is delta u is equal to minus f dot dr, and f dot dr is f dx because it is positive. Okay, so it is just that I have taken, right, point A, which is far away from point B. I'm bringing an object toward this M1, and in that it is bringing the object away from M1. Okay, that's why the sign. Okay, everyone. So next concept. I hope all of you understood this concept of potential energy. Anyone have any doubt in potential energy? Please tell me. If not, then please raise your hand. Clear? Okay. Because see, right? So what I'll be doing, okay, from next week onwards, okay, we will be having 2 or 3 lecture classes and 1 full problem solving class. Okay, full problem solving class, right? So most probably next class will be full problem solving. We will just discuss the problem of all the concepts. Okay, and I will give you the problems beforehand. Okay, solved examples and all the things I'll give you beforehand. Okay, so next concept is called as potential, not potential energy, potential. Okay, now let's define potential. Let's define potential first. Again, I'm talking about the general term. Okay, potential. Now, I hope all of you have heard this word potential, right? That I keep saying that you guys have lots of potential. Okay, so what's the meaning of potential? Tell me, what is the meaning of potential? What do you think? Ability to do something, right? Ability to do something, or capacity. Yes, Karishma? Okay, right? And here we are talking about what? Work, right? We are talking about work. So can I say that, okay, I can define potential, right? I can define potential as the ability to do work, right? But how can I know, like, how can I measure that? Okay, so I can say that, okay, let's say potential, right? Potential is defined as amount of work done, amount of work done, right, per unit mass. Okay, right? Agree? Right? So I can say that, okay, potential will be the amount of work done per unit mass. Yes or no? Tell me. Think about it, guys. Right? I'm just talking about the general definition of potential. Now, what's the meaning of work done? What's the meaning of work done? Tell me. Yes. So yes. So work done is basically force into displacement, right, everyone? Work done is force into displacement. So if I see this, right, see, so gravitational potential. So I can define gravitational potential. I can define gravitational potential as the amount of work done, in bringing a unit mass, from infinity to that point, okay, from infinity to any given point without changing its kinetic energy. Okay, right? So the potential can be defined as amount of work done in bringing a unit mass or unit object. So here we are talking about mass. So unit mass from infinity to a given point. Okay, from infinity to a given point, right? Now what has changed? If you remember the definition of potential energy, so doesn't it sound similar, right? It's almost similar, right? The only difference is when we talked about potential energy, we didn't talk about mass. It can be of any mass, right? Yes or no? It can be of 2 kgs, 3 kgs, doesn't matter. We never talked about mass. It's just that amount of work done to bring one object from one point to another point, right? Negative of work done, right, everyone? Am I speaking too fast? Please let me know. No, right? Okay, very good. So when I talk about potential energy, we just said, okay, it is the negative of work done to bring an object from one point to another point. Okay, but when we talk about gravitation potential, right? Gravitation potential, okay, it is the amount of work done to bring an object, right, of unit mass from infinity to that point. Okay, got it? I hope all of you understood the definition. Right, everyone? Okay, so let's see, right? So this is basically the amount of work done. So it is basically, yeah, integration of f dot dx, right? Okay, by m. This is v, or potential difference, which is delta v. So I'll just write as delta v. This, I'm writing the general expression. Why I'm writing the general expression? Because if you want to calculate the potential because of anything, okay, because of anything, you can just use the integration. Okay, you should know the value, or you should know the basic formula from where the other formulas are derived. Okay, right? Okay, now let's see this. Now we know that F is, when you talk about gravitational force, it is G m1 m2 by r square, right? Okay, gm1 m2 by r square, but it is by m, so m will be cancelled. Okay, there's some mistake over here, they just removed m. Okay, right? Oh, sorry, they just used m is equal to 1, mass 1 unit, right? So just used mass is equal to 1 unit. Now if you see the integration, if you remember, we have seen the same integration in gravitational potential, right? Same integration as gravitational potential energy, gravitational potential energy, same integration, same thing. Everything was same, right? The only thing which has changed is now m2 is equal to 1, as simple as that, right? As simple as that. Okay, right, everyone? Okay, so anyone have any doubt in this? Tell me, right? So if I derive, so this will be equal to what, right? It will be G capital M small m by m integration of 1 by x squared dx. So mm will get cancelled. So G capital M integration of dx by x squared, right? Depending on if you're bringing from infinity to a point r. So we will get G capital M minus 1 by x r to infinity. So this will be minus G capital M by r, right? This is your, tell me, delta v, which is VR minus V infinity. Okay, got it? Now, if you use two different points instead of bringing from infinity to R, if instead of bringing from infinity to R, suppose I want to find delta V, which is V from point A, right? Sorry, VB minus VA, right? Which is going from point A to point B. Then tell me what will be the formula? It will be G capital M minus 1 by X, right? This will be RA to RB. Yes or no? Tell me yes or no. Right? This is basically G capital M by RA minus G capital M by RB. Sorry, RB. I've just adjusted the sign. Okay, I just adjusted the sign. Make sense? Tell me, make sense? Right? Because according to this equation, VA is equal to minus G capital M by RA and VB is equal to minus G capital M by RB, right? Even if you put this or subtract, you will get same. So I hope all of you understood the definition between difference between force, field, potential and potential energy, right? Because this is just the start. This is just the start. Okay. Now let's see. Let's see the relationship between force, field. So I'll just write over here force, field, potential energy, potential, right? So force F is equal to G m1 m2 by r square. I'm just talking about the magnitude, right? I'm not talking about the direction. Field is, right, or G is equal to, tell me, F by M. Okay. Potential energy. What is potential energy? Delta U, right? Delta U, which is minus integration of F dot dr. Okay, right? Or F is equal to minus du by dr. Okay, then what is P? P is equal to integration of F dot dr by M, right? Or can I say that, okay, it is minus delta U by M? Think about it. Think about it. Or if you observe, see this, I'll write it as I'll write it as I. It's better to write I is equal to F by M. See this and see this. F is M, okay, M is constant. I'll just put it over here. So it is integration of F by M dot dr. Ring a bell, ring a bell. So this is integration of I dot dr. Tell me yes or no. Think about it, yes or no. Yes. Okay, any issues till this point? Any issue till this point? Anyone have any issue till this point? Okay, very good. Now let's see for point charge. For point charge, I'll just make this list one by one for point charge. Okay, for point charge. For point charge. Force. I'm just writing this. Force is equal to G m1 m2 by r square, right? Field Ig or just G, doesn't matter. You can write whatever you want. G capital M or just M1 by R square delta U, right? I'm just taking from infinity, okay? So I'm taking it away, right? If I'm taking it away, then it is negative, right? If I'm taking toward, then it will be positive. So I'm just taking it away, okay? So minus G, tell me, M1, M2 by R, okay? Where it is taken from R to infinity, right? And V, potential, which is G M by or minus Gm by R. Tell me, yes, है ना? Because it is, see, delta U by M, delta U by M. So minus Gm 1 by R, or this integration, and it is taken from infinity to R. This is taken from infinity to R. So this you have to remember. This you have to remember, okay? This is R to infinity, this is infinity to R. If it is also from R to infinity, it will become plus. Right, everyone? Anyone have any issue till this point? Tell me, anyone have any issue till this point? I'm trying to teach you half of electrostat. Okay. Okay, very good. So I guess this is clear. Very good. This is clear. Now, what is your homework? What is your homework? Okay, homework is right 8.1 complete. 8.1 try as much as you possible, right? And DC Pandey, right? Need students. DC Pandey, solved examples and whatever you get, solve. Okay, right? So these are the problems that you have to solve on your own, right? Plus, I will give you some problems. You have to solve this. Plus, find potential. Find potential due to A, solid sphere. Solid sphere. B, hollow sphere. Hollow sphere. C, ring. Okay. HCV, half of the portion is completed, right? Half of this is completed. So HCV, I'll just tell you which questions you have to apply, solve, right? So I hope all of you have HCV. Everyone have HCV? Yes? Okay. So by sharing it, does it send like, because I don't make a proper notes of one note, right? Okay. Okay, I'll just ask someone to take some snaps of HCV questions and they'll send in the group, okay? Wait. Okay, I'll just figure it out how to share, okay? Because there are some random notes also, okay? So I don't like want everything to be shared. I'll just try to convert into PDF and share then, okay? Okay, I hope everyone understood today's class. Just raise your hand. I hope all of you understood today's class. Aryan, Shrihari, Tulip. Okay, very good. Tulip left, I guess. Samya, Shreya. Okay, thank you everyone. If you find any kind of difficulty, please let me know at that point only. Okay. 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 Thank you everyone. Bye bye. Take care. Bye everyone. Tomorrow we will have advanced class. The time would be 1:45 to 3, most probably. Yeah, 1:45 to 3. Okay. So I'll try to give some problems, good problems, and we will discuss those problems. Okay, right? Some derivations plus some problems. So those who want to join, they can join. It's completely optional. Okay. Okay. Bye everyone. Take care.